Hello students, today we are going to discuss about the new topic about the interstitial voids or interstitial site. So when the close packed structures are formed, that time there is a vacant space left in between the constituent particles. This vacant space left in between the constituent particles is in the closed packed structure is called as a interstitial void or interstitial site. There are two types of the voids are there, the tetrahedral void and octahedral void. Let us start the first tetrahedral void. Now you can see in the figure on the screen there is a figure is shown about this tetrahedral void. The vacant space or we can say void among four constituent particles having tetrahedral arrangement in the crystal lattice. So you can see there is a we can say one vacant space is shown and it is formed among the four constituent particles having tetrahedral arrangement. So that type of arrangement if it is there in the crystal lattice, then that vacant space is called as a tetrahedral void. If you see the figure, then you can say the shape of tetrahedral void which is shown there, it is not the tetrahedral but the arrangement of the four spheres around the void is tetrahedral. The line joining the center of four atoms forms a tetrahedron. A tetrahedral void is formed when a triangular void made by three coplanar spheres is in contact with the fourth sphere above or below it. You can see the first figure or even you can see the second figure. In that there is a we can say triangular void is there. It is made by three coplanar spheres which is in contact with the we can say the four spheres, one three in the plane and four either above or we can say below. Then that time we can say that that void is the tetrahedral void. Let us see the characteristics of tetrahedral void. The volume of tetrahedral void is much smaller than that of atom or sphere. Second characteristics, larger the size of sphere, more is the size of void. Third characteristics, the coordination number of tetrahedral void is 4. Then fourth characteristics, if r is the radius of constituent atom, then the radius of tetrahedral void is 0.225 r. And fifth characteristic, if the number of close packed spheres is n, means in that unit cell suppose there are the n number of capital N number of the spheres are there, then the number of tetrahedral voids are 2n, means double of that. If suppose n spheres are there in the unit cell, then there are the double number, means 2n number of the we can say that the tetrahedral voids are there. So you can see in the figure the tetrahedral void in unit cell. The void is there, it is surrounded by the we can say that the four spheres one that is shown by A, B, C, D, and it is in tetrahedral manner, so it is called as a tetrahedral void. Now let us start the octahedral void. You can see the figure, in that unit cell, the one octahedral void is at the center of the body of the unit cell, and you can see it is shown in the we can say at the edge of the unit cell. So like this we can say now in the unit cell there are the 12 edges are there, so we get the 12 the 12 centers at the edge 1 and 12 voids we could get on the edges 1, means 1 at the body center and 12 voids at the 12 edges, the centers of the 12 edges. So let us see the octahedral void means what. The vacant space at the center of 6 spheres or atoms which are placed octahedrally, means when the vacant space is formed if the 6 spheres or we can say atoms are placed octahedrally, then at the center of that we can say that these 6 spheres or atoms, then that vacant space is formed. That vacant space is called as a octahedral void. See, let us see the clear about that one. Define again. The vacant space or void at the center of 6 spheres or atoms which are placed octahedrally, means when the 6 spheres or atoms which are placed octahedrally, that time a vacant space is formed at the center. That vacant space is called as a octahedral void. Let us see the characteristics. The characteristics of octahedral void. The volume of this octahedral void is small. It is, we can say that, is smaller than the tetrahedral void also. There is one octahedral void at the body center and 12 octahedral void position at 12 edge centers. In the last figure we have seen that there was a, we can say, one octahedral void was shown at the center of the body and 12 octahedral void position at 12 edge centers. As unit cell has a 12 edges, so we can say that at the center of edge one void like this, there are the 12 edge centers are there. So 12 voids, octahedral voids we get. If capital R is the radius of constituent atom, then the radius of octahedral void is 0.414 R. So here the radius of that we can say that this octahedral void is 0.414 R. So we can say octahedral voids are little bigger than the, we can say that, the tetrahedral voids. The coordination number of octahedral void is 6. So this we can say that these empty space is there, it is surrounded by 6 spheres, so it is called as the coordination number of octahedral void is 6. Then if the number of close packed sphere is n, now suppose in that sphere, suppose we can say that in that unit cell, if the number of, we can say, sphere is n, capital N, then the number of octahedral void is also n. Means whatever number of the spheres are present in one unit cell, that many number of the octahedral voids are formed. So this was about the characteristics of octahedral void. So students, go through this video again, watch the video again and complete the homework which is shown on the screen. So complete the homework. Okay, thank you.